All right. So because we are not using a Raspberry Pi and we're not using something that has a built-in I2C, we have to use this little board, which is our FT232H from Adafruit. It is a multi-protocol USB I2C, SPI, and GPIO input-output board. And we want to connect up this AMG8833 thermal sensor. So in our code, what we had to do was first we bring in sys, we bring in os.path, we let this do its thing. We have from time, we imported sleep, we had import numpy as np, we have import cv2, which is Opencv2, we have import os. What we're doing here is we are setting an environment variable, which is blinka underscore FT232H, and that is set to 1. And what that is doing is that is allowing our system to actually access this chip. Next thing we're doing is importing busio, and we are importing board, and we then are importing adafruit AMG88xx, and then we are importing FTDI, but from that we're importing pyftdi.ftdi, and we are importing FTDI from that. And then what we're doing is we first are identifying that our system is working. So what we're doing is we are opening FTDI open from URL, and that is FTDI equals / FTDI : 232H:1/1. Then what we are doing from there is we are assigning our I2C bus, and what we are saying that is busio.I2C board.SCL, board.SDA. So what that's doing is that is assigning our pins from our board here. And what we had to do on this board to make sure that it worked with SDA and I2C is we had to connect up our voltage through our 3-volt. We have our ground, which is connected to our ground. And then in order to get the SCL to work, we had to, well, first connect that up to the SCL, which is our clock. And then for SDA, which is our data, that had to be a combination of the MISO and the MOSI port on this chip. So those two connected had to daisy chain into one row to give us our input-output, and that is muxed once it gets to that chip. So that is where we are defining what is the SCL and the SDA. That is the SCL and the SDA. Then what we do is we are initiating the adafruit library for the AMG88xx. We're bringing in AMG88xx, and we are telling it to access that on these two ports, and we're calling that sensor. Then what we do the first time we run this code is we sleep for a millisecond, and millisecond. And we let the board come on, and then we are pre-allocating the matrix called numpy, and that's just a list here. And then we start with a try, and while 1, so while 1 is also the equivalent of while true. What we're doing is we are assigning normal pix equals np.array sensor.pixels, dtype equals numpy unint 8, and unint means unsigned integer, so there is no plus or minus on the integer. And then just to break this down a little further, what sensor.pixels is doing is reading from the board the integer that reflects the pixels coming in. Then what we're doing is we are creating a blank numpy array called IMColor, and this is numpy zeros, so it's making an 8x8 array of zeros, and those are unsigned integers as well that are 8-bit. Then what we are doing is we are applying a normalization to our data set, and the normalization is taking the input of what's coming out of the sensor, and it is putting it into this IMColor, and what it's doing is it is pulling the data from the top and bottom of the pixel values, and it's making the lowest value equal 0 and the highest value equal 255. From there, what we're doing is we are printing that, which you are seeing right here on the in the terminal output. And from there, what we are doing is then applying what is called a color map in Opencv. And the color map basically just turns the black and white information into color information. So this looks prettier than just looking at a grayscale. Then from there, what we are doing is we are resizing this because our original data set is actually only 8 by 8, which would show up really small on the screen. So we are actually turning it into something that is larger than 8 by 8 so that we can see what's going on. Looks like I just realized we have some feedback going on this crazy video. Doesn't matter. So 8 by 8, we turn it into 512 by 512, so it runs and we can see what's happening. And that's what we're doing here. We're resizing it. And then we have this line of code, cv2.imshow thermal normal pix. It's taking this input, putting it here, naming it thermal, which you can actually you can't see, but the name of the window that the data is in is called thermal. And then we have k equals cv wait key. So this is just needed for the loop that is in Opencv. And then from there, we have if k equals 27, which equals the escape key, we break this loop. On the exception, it says that the Control-C program stop to be a keyboard input, and then finally exiting loop. This is if we have an exception, and then finally it says exiting loop. So if I were to bring this down to the bottom of here, and I press escape, look at that. Exiting loop, and we are done. So that was fun. The next step in this project is going to be twofold. One is mounting this little thing inside of a little box and also wiring it up with some vinyl wires so that we don't have to be using our project board or our what's it called, our breadboard and these testing cables. And then the second step after that is figuring out an efficient way to get this to run inside of OBS. There are two things I'm thinking. I mean, the easiest way that we have here is we're just screen capturing. But, you know, drawing on the screen and having to deal with that is not the most efficient way to do this. What I would like to do is possibly enable MJPEG streaming and create a little web server that is streaming out the data as MJPEG and allow OBS to import that as a video stream and go with it there. But ultimately, the best way to do this would be to be able to create a virtual V4L input device. So it makes pretend that it is a webcam coming in and just sees it as another webcam device in OBS. That would also be really cool because it would let me stream that out to any other platform like a webcam. So basically it's building a Python script that when you run it, it's basically a driver. So thanks for tuning in. I'm gonna sign off now, and later tonight I might come back and either work on this project or get back to work on our PPE-com. So if you like what you see, please subscribe. If you haven't subscribed, if you have any questions, please feel free to message me. Thanks for tuning in, and catch you later.